Okay, you see, coffee has done its job. The coffee has done its job. This is a power supply for an 80. This is a power supply for a 5Y3. Are they necessarily the same? Well, let's just take a look. So if you look at the heaters for the number 80, you can see the takeoff for the positive voltage comes straight over to the first capacitor, then a resistor, then the resistor in question. Straight from the number 80 straight to the filter capacitor. This is where the number 80 would be, but it's not a number 80 in this radio. So the heaters are these two. The high voltage are these two. The set has not been on today, which is why I'm sticking my finger in here. There has to be a wire coming from the heaters carrying the positive off to the power supply, to the filter part of the power supply. If I look very carefully, there is a wire, it loops down, it comes to this terminal here. From the 5Y3 to and through these two resistors. Oh, well, that's totally different. That's not what this shows. This doesn't show it like that at all. Yeah, wrong schematic. Okay, maybe that's part of what's going on here. So I'm going to do my best again to get the right schematic in front of me. Okay, we'll look at the proper schematic in a minute. It's totally different. It's totally different. So, coming from the rectifier here, I can see a wire coming around to here. What's a little harder to see is another wire leaving this terminal, heading up and around and coming up and going right up to the capacitor here. So it's coming from the tube to the capacitor, but there's also resistors there. It's definitely red, black, orange. It's definitely 20K, 2 in parallel, definitely 10K. So we need to look for 10K in the proper schematic, and we should find this connection over to the filter capacitor. Okay, let's cross your fingers on this. Okay, here we are. So here's the 5Y3. Very good. Good, correct schematic. Here's the positive lead coming out from the rectifier. Oh my gosh, this is really hard to look at. If we go in one direction, we run into a 12K. If we go the other direction, we hit a 1500. What happened to the capacitor? What happened to the 10? Is there a wire sneaking around here somehow? Some sneaky wire? I don't see a sneaky wire. Look, you can. This is open here, right there. That's the only crossing. That's the only guy coming out of here, coming up here. What do we got? We got another version of this radio, other than the schematic I'm looking at now. Fif 1500. It goes through the 1500 to get to a filter. Wait, that's not even connected there. Where is this going? Okay, assuming that's not a dot. Oh, there we are. It comes down here. Save themselves a dot by not putting a dot here. Okay, so this is connected here. So basically it's through a 1500 over to the first capacitor. Then a 10,000, R27 now. R27. R27. So resistors are, well, whoa, and the numbers don't go up to 27. 27. RF coils. Miscellaneous. Big blank. Yeah, that's where I'm at. Big blank. I can get rid of this one, actually. Well, so I'm sure this chart doesn't go with the radio I've got. Well, here's a picture of the radio. Or some radio, anyway. Some radio similar to the one I've got. Now, of course, this is upside down from what I'm looking at, so that helps. So you should find two paralleled resistors. They would be going on an angle like this. See, here's a big one here. This kind of angle, two paralleled right in here. There's something big here. It's a great photograph. 27. Wasn't it 27? 27. 20, anybody see 27 on here? Oh my gosh, there's 28. 27. 24. 23. 27. What? What is going on? You know what? It's going to be up to me to sort this out. I think the schematic is just going to be misleading all the time. But how can this resistance test I took be so misleading? Let's take it again. We're going there. There's no question, it's here. It's here and there. These clip leads go to my ohm meter. This should be 2 20s in parallel, 10. The math isn't that tough. There it is. Holy smokes. And you know, it's not even worth looking for a replacement for these, unless I stick a wire wound one in there, which I think is verboten. I think. I've done it in other radios when I didn't realize it was verboten, but I think it would be a huge mistake to put a wire wound resistor there. How can this be? So if I decide I'm going to remove one of these or both of them, I'm probably not going to be able to reinstall them. So I could lift them out one lead, test them, find out they're okay, but I can't reinstall them because I've cut the leads. And unsoldering them and unwinding them looks like a... Well, you know, maybe it can be done down here. I doubt it. No, they can't. They're going right through and they're wound around. I can see it. Holy smokes. What a quandary. And the radio works. This is just burning my brain up here. What could I possibly be doing wrong? Any other path in parallel with those resistors should just drop their resistance lower. It can't go up because of that. Another ohm meter. That's a really ridiculous idea. Okay, let's try that. Just I can't imagine another ohm meter. Let's get this old guy going here. R times 1000. Now this, I may not be able to zero this guy up properly. Let's see. We'll give him a little bit of time. In the meantime, I'll get the leads ready. Now, to do an ohm reading, I'm pretty sure this has to be flipped over here. There's a little switch here. There's a resistor inside here. Okay, well, we're going to go right across these resistors. That's definitely there. Okay, we'll just take a reading and worry about the scale after. Yikes, let's short this out. Okay, we may not be using this meter. Isn't it supposed to go? Oh, well, how about putting it on ohms? Now that's helpful. That's a helpful move. Ohms adjust. It's way off. Okay, there we are. Infinity. 0. Come on, you can do it. What happened there? This meter may have a battery inside of it, and that battery may be really incapable. This is not going to work out very well. Well, we'll try that, because after all, it's all about having fun. Okay, so we'll go there, go here. We get a reading. I can see it. I can see it falling. It's probably because the battery in here is bad. So it's close to 10. It's close to 10 times 100,000. Come on. No, wrong scale. No, right scale. 15. R times 100. Oh, a top scale, Jim. What are you doing? Read the top scale, the ohm scale. And in that case, we read times 100, 10 times 100. It's the same number. Just happens to be close to 10. You're on the other scale. Well, 10 times 100 is 1,000. It's supposed to be 10,000. Okay, now there's a reason why I don't usually make ohm meter readings with these meters. We need another meter. We need another meter. Where is the other meter? There it is. No, yeah, let's see. Okay, here's one. This is really intended for doing car work. Let's try this one. Okay, we're going to steal the leads from here. Common, volt, and ohms. Ohms. $2,000K. What's this even mean? 2,000K, so it would be 2,000K. So this is 150K. 150,000 ohms. We can go to this scale. Yeah, there we go. This is the 200K. So that would be 200. So it's 118. You know, sometimes the resistors are bad. You can like physically move them and they do stuff. Well, I'll be that jumped around, didn't it? Please, don't be bad. You know, when I first looked in this radio, I thought, well, those will be good, those will be good, that'll be good, they'll all be good. Common. Here, let's repeat the flexing of the resistors. We're getting a different reading now, down here. Look down here a little bit. Look down here. Okay, so moving the clip leads. Pretty steady. Moving the resistors. Oh my gosh. I barely touched them. So what can go wrong? And I've got an excellent resistor here to show you. So when I replaced the resistor earlier up here, I put a new one in up here now. First resistor I put in was this one, this type. I hate these resistors. I have a lot of them because of this. They come apart so easily. It's like a little cap. It's going right on the carbon here, or whatever material that is. Right on. Often when I'm putting these resistors in, they pop apart, and it makes me think these just cannot be reliable under any circumstances. And I have a lot of these, so that's why I tried using it. And while I was installing it, it popped apart. The same thing can happen inside these resistors. There's a contact somewhere achieved in some way That's the resistor company's business, how they do this. But those contacts inside can come off. As I get open resistor sometimes, it's not because the element has burned out, although it could be. Sometimes it's just because the connection has separated. So these are terrible. Like, you heat these guys up. Let's heat them up. Let's heat them up and see what happens here. Hang on a sec here. Okay, I'm gonna heat them up. I'm gonna watch the meter. Oh, how'd that light come on? So this is about, it's not hot yet. Oh, it's pretty warm. Okay, here we go. Start heating and watch the voltmeter. Oh my gosh. I thought they would go up. I mean, this couldn't have heated it very much yet, but it's not burning my hand or anything. This is 100 degrees C air supposedly coming out of there. So it's a boiling point. What to think? Imagine you're heating them up, things are expanding, maybe contacts are getting better. But is it going to get down to 10? Wow. Take it away now. Just going to step in front of the camera here. Okay, and expect this to go back up to 100 and something eventually. Well, all evidence is these guys are bad. Yeah, it looks like it's starting to go up now. Jeepers creepers, that would change the operation of this radio as you used it. You know, you ran it for an hour or two. Wow. Lessons learned here. Well, I gotta stop and think about the situation now because obviously some action has to be taken. Okay, so just a little bit of research, and of course the issue with wire wound resistors in a radio is in the RF circuits where you have radio frequency signals, and the coil of wire in the resistor might play an influence there. In a power supply, not really a concern. In fact, there's a wire wound resistor right there. Okay, so my concern about this was false, and consequently I've now got two resistors here that I could use. They're both 10 watt resistors. That's fine. I just make them cooler. But we should check them for their resistance. Let's see what we get here. Wow. 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 Calibrate your meter with this one. Holy smokes. I'm going to put the older one in there. I also have this, which I wouldn't use, but let's test it. Oh, wow. It says 10 on it. Wow. That's that's amazing. Okay. I'm going to pop these guys out. I'm going to put this guy in right in here. I'm going to test these when I get them out. Actually, I should just cut it and test them right now. Just in case somehow I have moved this whole thing up unbelievably. I don't think so. Let's pop these right here. Maybe one of these is bad and the other one isn't. Although it's hard to explain the results here. Let's see what happens. Now, I've done stuff like this before, absolutely convinced of something, but then upon further testing, no. So this should be a 20. Oh, 60. 60,000. What about this one? Oh. Oh, this one's gone. This one is open. Well, there's a lesson learned. I was so happy. They looked so great. I thought wonderful. I thought wrong. Okay, so I'll go ahead and do the install this, and we won't have another problem there. Okay, hooked up my ohm meter, which you can't see just now, and we're supposed to get a reading of 35,000 ohms. Look at that! Hot diggity dog. Okay, wow. That was pretty interesting. That was very interesting. And now we've done 2 jobs here. You know what, I haven't finished testing the resistances on this. You know, that change is going to affect all the tubes because the screen voltages must have been off everywhere. And wasn't there a moment when I was playing this radio and the volume suddenly got greater? And I thought, well, what was that? You know what that probably was? That was probably the heating effect on the old resistors here suddenly causing them to change value. And that's probably what that was. But it could be more of the same in this. I mean, look at these guys. Look at this guy. So it has been my practice in the past to notice, there's another high wattage resistor. Notice these high wattage resistors and check them. Simply because they tend to run warm. And the warmer and the hotter things are, and the more their temperature goes up and down, the more likely they are to suffer a mechanical failure, which is the usual story in these guys. It's not usually insulation failure that's happening in a radio like this, or most electronics or electrical systems. It's not insulation failure most of the time. It's a mechanical failure, often in the connections. And of course, there's connections inside all these parts. Very good. I got to continue doing the resistance measurements. So let's do that. Let's just keep going here. Let me put the meter over here. The next one, okay, we just did pin 3. And that turned into a big story. So I come down here with my powerful vision 42K. Looks like 18 there. I can't read it. 42 is next anyway. Pin 4. So this would be pin 4. That's probably close enough. 4. And then the next one is 18 and then 112. So 18 here. 112 ohms here. Oh, 24. 24. Did I skip one? $18, 11, and 30. 18, 11.1, and 33. Ooh, this is 33. 33. We got 38 there. Should be 0.1. This should be pretty much a 0. It looks like 0.1 on my meter. This one should be 31 ohms. 31. I just can't read this table. 11. That should be 11. This one. It's double. So there's a lead going from here to here. There's a coil in behind here, I believe. Goodness knows what's happening after that. 24 everywhere. Well, I'm not going to worry about that one. Again, the radio largely functioned. And then the next one, so the next one that seemed to be out a little more, it should be 18K. 18K here. Well, there we are. Okay. Good. Let's operate this thing and see what happens. It's a good time to make sure I haven't. So this meter has no auto off. That's why I don't normally use it. It's just about every time I use it, I kill the batteries in it. Okay, Mr. Radio, let's get this out of here. Put this over here. Oh, someone at my door. Okay, time has come here to test that radio. Let's see. Volume down. Switch is off. And the band we're on is band number 1. That's good. That's good enough to do it. There we go. Now, I made big boo-boos here. Smoke gonna come out. I think I have to turn it on. I think that's part of the deal here. Here we go. Okay, dim bulbs indicate things are good. Give it a moment. Can't imagine anything's going to get stupidly hot here. It's ice cold. Cold. It's not the best thermal sensor, sticking your finger in a radio, but okay, give it a full power. We're now hooked up to Niagara Falls. The great generators at Niagara Falls are powering this radio. A little volume, please. Yeah, I'm just checking to make sure the speakers are still connected. And shut off. You know, these red flags here that they've put on, they've colored some of these red, and they indicate, the idea is you flip everything to red and you're good to go. That's handy. Hello. Oh my gosh, that's full volume. It's not good. Not good. Oh, I don't have an antenna on it. Okay, let's put an antenna on it. Oh yeah. Hey, what happened there? How'd that happen? I touched the antenna. Got a very loud rush from my finger, but I just touched it. But it was better afterwards. Okay, unknown. Volume down, finger on. I've got the antenna here. Oh, this is not. No, my antenna's switched off down here right now. So my finger. Well, I could use my loop antenna. But let's just do this. We just want to make sure the set operates. Loose screw. Yeah, loose screw. Put it this way. Danger gem. Oh yeah, look at that. She's working. It's still a radio. Okay, we'll power off. Now, anything get hot? That got warm. Ooh. Oh, that got really warm. Ooh. That got warm, not hot. Those are warm. I'll have to bring in my thermal viewer at some point on this. Well, I think I did the radio a great service by discovering these resistors and getting rid of them. Good show. That's a pat upon the back because I have to do it myself, and that's great. So I'm just going to carry on the next video and just continue on through it. Thanks for watching.